Hello. Well, this is a brief explanation of what I've done with my DICOM proof of concept. I made some slides. So first of all, some definitions and basic concepts. DICOM, it's a file format. It stands for Digital Imaging and Communication in Medicine. And this format is a standard for storing and exchanging basically digital images. Then there's the PACS, which stands for Picture Archiving and Communication System, and that's a whole software that can store, manage, exchange, and retrieve medical images. And well, it has a lot of bells and whistles, but basically this is the software that allows to acquire, to see, to archive the medical images, usually in the DICOM format. So I mean, my proof of concept is basically on the format. It's not a whole PACS system. This is like a very simple schematic of the DICOM format. The DICOM format already in the current standard, it considers thermography. There's a modality TG, which stands for thermography, but that's about it. I mean, there's no additional information mentioning thermography in the standard. Something that's very important for thermography to save it in a standard format is that we need to preserve the original radiometric information, and that's very important. I mean, in order to do interpretation, like remote interpretation, telemedicine, for example, or to do like big data analysis. I mean, if you need like 1 million thermographies to train an artificial intelligence algorithm to diagnose or detect whatever, I mean, usually those million images are not going to come from the same center or from the same imaging system. So there's where having the radiometric information is important. So you can have basically just the temperature matrix and use that to feed your artificial intelligence software. Actually, DICOM for thermography is not new. There's been a lot of groups who've been interested. I mean, who've done work on establishing or making a DICOM converter, but to be honest, I haven't found anything, just journal publications. I know there's people in Poland who's published papers, and they mentioned that DICOM is the way to go for thermography. Or there's also people in Portugal that they've done. I mean, they've mentioned that having a DICOM system for thermography would be ideal, but I have yet to see a software that does it. I mean, it's just like words written in a paper. The closest thing to a proof of concept, which is basically what I did, was this journal proceedings that was written by Francis Ring in 2006, where he basically took images from a software named CTherm, which actually I've never heard before. I looked it up on the internet. I couldn't find any information about that software, or I mean, I don't know if it still exists, if you can download it or what, but I couldn't find nothing about that software. So basically what these guys did in this paper was sort of a proof of concept. What they took an image from CTherm and convert that image into the DICOM format. Here we can see that they converted this image from CTherm into DICOM, and they opened it with a traditional DICOM reader. I mean, those DICOM readers and writers, you can download them for free from the internet. However, I don't think this one has radiometric information. There's ways around figuring out the radiometric information by putting the lower value of temperature and the highest value of temperature, and then figuring out the temperature on each pixel, but it's basically not the raw data that comes from the thermography files. Talking about files, well, every single camera has their own proprietary file format, and well, I'm not sure. I don't think they give information, like specific information on their formats. FLIR does. They on their website they have their software development kit for MATLAB. So with that software development kit, you can extract the radiometric information from the FLIR images. So that I can do, and I can have the radiometric information from the FLIR files. And now that I have the radiometric information, I can put it into a DICOM file. Let's see. So how do I put that radiometric information into a DICOM file? Well, what I do is I put this temperature matrix is as another frame in the DICOM format. I mean, the DICOM format allows you to save several frames, not just one. So one of them is just the image, which can be the JPEG file, and the other one is the temperature matrix. The thing is that once you put the temperature matrix, I mean, it's not a traditional DICOM file, and it would be hard for those free DICOM readers to read those files. So once that we have the radiometric information in the DICOM file, we need to develop our own viewer, so that viewer knows that thermography file in one of the frames has the radiometric information. So that the reader gets that radiometric information, displays it, and then you can do whatever you want with it. Also, I mean, that reader can grab 1 million thermography files, just get that particular frame with the radiometric information and do the machine learning analysis for big data applications. And now that's the explanation. I'm gonna show you the proof of concept. Let's see. Here, I have a folder with several files. Here you can see this one, FLIR 4760, which is basically the name of the file that comes from a FLIR imaging system. I just put radiometric in there, but I mean the name that comes right out of the FLIR imaging system, which is FLIR 4760. That has radiometric information, and you can see how the size of that file is 1 megabyte, right? So I also have here a Bfief 4760 non-radiometric file, which is also a JPEG file, but it's only 100K. That doesn't have the radiometric information. So how did I get that non-radiometric file? Well, I used the software development kit from FLIR for MATLAB, and I split the radiometric file into the JPEG file and the temperature matrix. So this is the radiometric file. This is the non-radiometric file. So basically, if you might think it's the same file. I mean, it's basically the same file, but it looks exactly the same. So how come one is way larger than the other one? Well, that's because the radiometric file has this, the temperature matrix of every single pixel. So with the MATLAB software development kit, I can split that file into a text file with all the temperature values and a image file, which is basically a simple JPEG file. So those two elements, I can insert them into a DICOM file as different frames. So when I read with my proprietary reader, which I haven't done, which is basically the PACS or the PAC system, the PACS. Well, with that you can read the radiometric file, but and see it and do whatever you want with it. Well, and here's my DICOM conversion proof of concept. First, I used Mathematica. Most languages, programming languages have a DICOM interface. So I mean, you don't have to program a lot if you know what you're doing. I'm not a software developer, so I use high-level programming languages just to make like pseudocode and just to show what needs to be done. So now that so that a software developer can later do it. So here's what I did in Mathematica. I converted a JPEG image, a radiometric and non-radiometric image, into a DICOM file. You can put the demographics here. They're also part of the DICOM file. And here's the temperature information. Here's is stored in this variable. You can see the temperature information here. Let's see, it's loading. So that's the temperature information. Right? Well, I mean, we don't need to see all those numbers. That's in degrees C. That's why it's 35, 32. I don't know if that's the units FLIR uses. I think it does. Or there's a parameter you can put in the software development kit, so you can do it in degrees C. So that matrix is 360 by 480 pixels. Each one it's a temperature, and I exported that numeric array into a DICOM file. That's called thermography numeric array.dcm. So there it is. So now I can import my DICOM file and I can see it here. So this has all the radiometric information, right? Here is my DICOM array, and I can use it however I want. I can also convert just the the image without the radiometric information. This is the non-radiometric image. I can export to DICOM, and then I can see it here. So basically, what needs to be done is this is the converter, and we need also the viewer. I mean, the PACS system, because once you set up the DICOM format for thermography, I mean, anybody who's involved with image processing or image software development, I mean, should be able to do this way better and way faster than myself, which I'm not a software developer. Anyways, but this is just a proof of concept. Since I wanted to make something that was more like friendly to people who are not experts in image processing, I started working on an interface to do this as a website. So I did a video right here of this same proof of concept, but with a web interface. So everything that I showed you here before in Mathematica, I did it again in Python. Python also has a PyDICOM library, so it can generate DICOM files, it can read DICOM files. So, I mean, you don't have like to reinvent the wheel. I mean, all those libraries are already ready to be used. However, you have to develop the software, and that would be basically, in my opinion, the PACS software. So let me show you the video. So here, basically, what we did is replicate. Oh, there's another important thing about Python. It's once you've done your program in Python, I mean, you can use another environment which is called Django or Django, which allows to make a website out of your Python software, your Python program. I mean, probably this all these things might sound like gibberish to people who are not involved in software development, but I mean, that's at the stage we are right now. I mean, we don't have a finished product. This is a proof of concept, and I'm pretty sure somebody who knows about image software development should understand what I'm saying. I mean, maybe they probably are more knowledgeable than myself, and probably they can pick up on things that can be done better, or whatever. So here it is. This is the graphical user interface based on the website using Django and the Python program, which I've already tested, that works exactly like the Mathematica code that I just showed you. And with this one, I mean, it's just a user interface where you put the image, the name of the image, the thermography image, and the output DICOM file, right? So this is the thermography image, which is radiometric. And now it's converting the image into a DICOM file. Now that the DICOM file is generated, here it is. We can use this viewer. This is actually DICOM commercial viewer. It's called micro DICOM. I mean, I did a video because micro DICOM only works in a Windows system, and I have a Mac. So I did a video in Windows. And now we can upload the DICOM file we generated, and you can look at it here. The thing is that this image here it's not a radiometric image. It's just the JPEG image, because this viewer, this DICOM viewer, doesn't know that we stored a temperature matrix in another frame of our DICOM file, right? In order for us to access that temperature information, I mean, we would need to make our own viewer. However, I mean, this is basically I do this. I know that it's not helpful for an interpreter to analyze this image, but I'm doing it just to prove that this file is indeed a DICOM file. I mean, it's not an image. It's not a proof that with a free DICOM viewer you can send it to an interpreter and change the settings or the emissivity or the lower temperature, the higher temperature, the palette or whatever. I mean, it's just the proof that this file is indeed a DICOM file. So, I mean, just as a conclusion, it is possible to save the radiometric information into a DICOM file. It can be done right now. However, we need to develop our special readers so they can take that radiometric information, which is the temperature matrix that I showed you, and display it and change it, or grab a million of those to make to train a machine learning algorithm. Another important thing is that this can be done right now with FLIR images. However, if I get an image from another camera vendor, for example, ICI, Spectrum IR, or whatever, I mean, I wouldn't know if I would be able to extract the radiometric information from those files. I mean, I can do it for FLIR because they share their file format information. For other purposes, obviously, they do it for inspection and industrial applications. I don't know if medical thermography vendors would be interested in sharing that information with us. I mean, we can tell them that, hey, this is the DICOM format, and they can put I mean, they will have to develop the code themselves and put it in their software, so they can export or maybe make an app that would convert their file to a standard thermography file, and with standard, I mean, to a standard DICOM file. And with a standard DICOM file, I'm talking about the one I just explained, which includes the radiometric information, not just the image. Because I mean, they could say you can convert it right now to a DICOM file, but you're just going to have the image, not the radiometric information. We have to store the radiometric information as another frame, and then we can gather the information from that frame. I'm aware there might be another ways around this. Like I mentioned, you can plug in before generating the DICOM file, the minimum temperature and the highest temperature. And then you can like calibrate the whole JPEG file into a bunch of temperatures. However, for example, this logo, I don't know, it's gonna be super hot, for example, in the process and all. I mean, it doesn't seem like the best way to do it. If you just include the radiometric information, then you're gonna see a clean image like this with just the temperature data. I hope I explained it well enough so most of the people could understand. And well, if you have any questions, you can email me or contact me. Well, thank you very much.